Good morning, honors pre-calculus students. Mr. Duranko here, picking up where we left off before the break. We're in section 7.5, where the topic is parametric equations. And I have to talk a little bit of physics here with you. Luckily, over half of you have taken or are taking physics, so you'll understand this. But those of you that haven't taken physics, I think that well, it's not too difficult and you'll learn a little bit. So we know, let's take for instance, when a basketball gets shot into the basket, it traces out the shape of a parabola. And in math, we can capture that if we plot that on a coordinate plane. And we usually have y equals negative x squared. Some equation would describe the shape of this. But we know in physics that the motion of that basketball is actually more complicated. If we follow the basketball as it heads towards the basket in just the x direction, we know that it will travel at a constant velocity. And so its x position versus time will look like a straight line. And the y motion is a little more complicated. It gets slower as it goes up because gravity is fighting to slow it down. And then it speeds up as it falls, as gravity pushes it back toward Earth. And that motion can be captured in this graph as a parabola, as you can see. But so in math, we were always lacking that time variable like we have here in physics. But in this section on parametric equations, we can turn these two equations into one equation that will capture the motion of that ball, and we can add the time component to the graph. And so let me give you an example, because as with almost everything in math, it's always more helpful to see a problem done out. If I, for instance, we'll notice that we have an instance where we can reduce these two equations with three unknowns by solving this for t, and then we can get one equation with two unknowns, which is exactly what we've been graphing in math for quite some time. If I take and solve this equation for t, and we're going to call t the parameter, hence the section parametric equations, and then plug that into negative x over 3 squared plus 2. And what comes out of this is what is called a rectangular form of those two equations. And so this is a rectangular form, and t was the parameter. And now I have a graph that looks like all the math that we've been doing forever and ever and ever. We have a function y as a function of x, and this graph looks like it could make that parabola. And so we've gone from physics to math, and we can actually capture the time in this graph by adding these little points, and I'm going to talk about how to get those points in the next lecture. This is called the orientation of the graph. And so I have a short assignment for you on just doing this, changing these parametric equations into rectangular form, and then we'll continue the section with the next video. Goodbye.